So I thought we'd do a lab today. But first, let's look at different types of equations, and then we'll start our lab. All right, so this is a general form of equations. Uh, we just use A's and B's and C's and D's rather than the elements. And so one type is like this. And kind of the opposite of this is when you have two things that react, these are our reactants, and then they produce something. So notice there's only one thing on each side. So going this way, it's decomposition. You know, like you throw something outside, like a sandwich, and let it just kind of decompose, it breaks up. This one is called synthesis, like photosynthesis. Synthesis means coming together. And so you got these two and they come together. So that's a synthesis reaction. That just allows us to categorize reactions as, just a general form, like, oh, it's this kind of reaction. Okay, now we've talked about combustion. Let's do that up here. Where you have a fuel plus oxygen, and then it makes CO2 plus water. So that's combustion. Now, there's only two more general forms. And reactions don't always perfectly fit in these, but this just gives us kind of like, oh, it's this kind of reaction. We can describe our reactions. So the last two are where we have two things and two things, or more than one thing on each side. And so say we have A, like we did this with copper. We saw copper come out. A plus BC, and then this one's more reactive, so it takes the place of that one, and so we get AC plus B. So one element goes in and one element comes out, and in this case, like we did, we had copper come out on this side. And then the last one, so let's name that. It's called single replacement. And the last one's similar, kind of like these two are opposites. Combustion is just combustion. Single replacement and then double replacement. Rather than a single element, now it's two compounds that switch. So let's see if we can fit this here. All right, so now we have two compounds. We have, let's change our color just so it kind of shows up. So now we have AB plus CD, and now they both switch. So now it's, let's say AD plus BC. Did I do that right? No, I did it wrong. See, when we think back to formulas, this is the positive one and this is the negative one, if it's ionic, which oftentimes it is. So we got to keep our ions straight here. The positive ones are first, the negative ones are second. So we need A with a D plus the C with the B. C, B, there we go. So now that's double replacement. It's two compounds, they both trade elements or ions to make something new. This is the type of reaction where we see precipitates. When you see a precipitate, it's usually this one. When you see an element come out like hydrogen bubbling away or copper comes out, single replacement. We form something, synthesis, something's breaking down, decomposition. See a big fire, combustion. And there we go. All right, let's do our lab. All right, so here's our players for our lab today. Let's look down. Some we've seen before. Copper sulfate. This is one. Sodium hydroxide. That's a really strong base. So something not to touch. It's ionic, sodium and hydroxide ions. So right now they're stuck together, but we're going to put them in solution. And then they're going to separate into sodium, which we know is kind of harmless. You need sodium in your body, sodium ions. That hydroxide ion, that's a strong base, and that's why this is kind of a dangerous chemical. And then this one, which is going to be hydrochloric acid. So you have to put some concentrated hydrochloric acid, which we do these concentrations in molarities, moles per liter. And so this one is 12 molar, which is really strong, nasty acid. 12 molar here in your stomach, your hydrochloric acid that breaks down your food is 1 molar. And so I got to add a certain amount here. I'm going to try to add it right up to 100 milliliters. Oh yeah, that's some nasty stuff there. Okay, so we're taking it down to 1.5 molar, just a little bit more concentrated than your stomach acid. So yep, you got hydrochloric acid in your stomach. That's what we got here. Now the last player is aluminum wire. Here it is right here. Wire made of aluminum. And so we'll use a piece of that. So, onward. Oh yeah, one more thing. So, things that are reacting, these are the little symbols we use. Can be a solid, a liquid, a gas, or aqueous. Aqueous just means dissolved in water. So our copper sulfate solution is aqueous. It just means that copper and the sulfate are dissolved into water. So aqueous. I still have some solid down at the bottom that's not dissolving, so maybe I put in too much. But I'll try to make it dissolved into an aqueous solution. So we'll do these reactions on a hot plate. The nice thing is it has this function besides heating. Turn on the heat, but we can also turn on the stirrer. What that takes is a little stirring bar. It's a little magnet. So we slide this in there. Still trying to get my copper sulfate to all dissolve. So I thought I'd use this. Then there's a magnet inside that stirs it, and so we'll just let that stir. Yeah, there it is. Maybe it'll make it dissolve a little faster. All right, now I think we got it pretty much dissolved here. Let's go maximum power on the. All right, so we got it dissolved. Now we're ready to start our lab. Let's turn that off. All right, here we go. All right, reaction 1. Let's take that magnet out of there. Not very magnetic. Oh, maybe because the other magnet? Yeah, that other magnet in the hot plate was causing me trouble. All right, I got it. All right, here we go. First reaction. Let me move you up a little bit. So sodium hydroxide and copper sulfate. We see that it's making it thicker. like a sludge in there. Kind of like a blue Slurpee. So I made a precipitate, which is a solid. Now what we're going to do is heat that. And so what we got in here is copper hydroxide now. It was sodium hydroxide and copper sulfate and sodium sulfate. So the solid we see is copper hydroxide, and we'll see that in our reactions. Now we're going to heat it. We'll turn on the heater. We don't really need to stir it. And we'll see what happens here. Let's get a look down on it. Oh yeah, good stuff there. Starting to see a color change. A little more color change. Starting to turn black. So we got her changed to a much darker color. Now that tells us that our copper hydroxide has become mostly copper oxide. So we lost the hydroxide. It broke down into just copper oxide and water. And so that's our black stuff there. So by heating it, we made it break down. And so it's a little decomposition there just from the heating. Now what we're going to do is take our hydrochloric acid and pour it into there. So we're going to see by adding hydrochloric acid what will happen here. We'll mix it with our stirring rod. Okay, so the acid's making it turn back to a nice clear blue color. All right, got it. All right, for our last step, we're going to take some aluminum wire and stick it in there. We see right away that it's bubbling pretty strongly. And so we'll let this go a little bit and then we'll come back. It's also the wire's turning dark and bubbling. Looks like we got some brown stuff on the wire. So yeah, we're definitely getting a reaction out of this. All right, so we're still getting lots of bubbling. So it's getting there. We'll let her go a little bit. Our wire's getting kind of brownish. So we may know already that that brown stuff is copper. So copper's coming out. We're also getting hydrogen gas that's coming out of solution. And so still got a little reacting to do. We'll let her go to the end. Kind of feel like it's taking too long, so I'm going to add a little aluminum wire, see if I can make it go a little faster. It's definitely exothermic. This feels pretty hot right now. So it's giving off heat as it reacts. We can see that extra aluminum's making it bubble even more. All right, maybe a little more aluminum wire. I'm getting impatient. go. Still bubbling quite a bit. Still going. Still going. Still taking a lot of time. And there we have it. So what we had was copper chloride, which is blue, put some aluminum in there. So this was aqueous, this was solid. And then we ended up with aluminum chloride in solution, which is a clear solution, plus copper solid. So this red stuff, red brown, it's actually copper colored, is copper solid. So there we go. We did it. It's in there. I see it. Ooh. Right, so let's just play around with this a little. Oh, that's a lot of like spongy kind of coppery stuff. Yeah. See if I can get it to come out. And poof. Oh, yeah. That's some good stuff. All right, let's get this out too. Oh, I got you. Come on, baby. Come on. Oh, yeah. There's some good stuff there. All right, so there's our last reaction. Produced some copper out of that copper chloride in aluminum chloride solution. The whole thing's pretty warm still. That reaction was exothermic. And there we go. Hope you have a wonderful day. See you later.